All right, let's take a look at lesson 11 from unit 7, reducing margin of error. So we're going to estimate population proportions and explore margins of error. All right, so 11.1, notice and wonder female leads. 5 students wanted to see how many children's movies have female lead characters. They each took a sample of children's movies, found the proportion of movies that had female lead characters, then used their results to simulate 100 additional samples. The table shows some of the findings based on the original sample and the simulations. What do you notice and what do you wonder? So some of the movies used in the original random sample, one of them used 20, actually 2 of them used 20, 2 of them used 30, 1 of them used 50. And you can see the estimated proportions in this column and the margin of error in this column. So some things you might notice, all of these estimates are between 0.2 and 0.3. As you increase the number of movies, the margin of error decreases. There doesn't seem to be a pattern between the number of movies and the estimated proportion. What do we wonder? We have the estimated proportions. What's the actual proportion? Why are these margins of error different? And is there a reason that the more movies in the sample, the smaller the margin of error? Does that mean anything? All right, so let's take a look at 11.2. Elena and Claire are each working on a project about how high school students are having trouble finding jobs. They each find the proportion of students without jobs from a random sample, then use a computer to do 1,000 simulations using the proportion they found and report the results. Elena says the proportion of high school students without jobs is about 0.70, with a margin of error of 0.280. Claire says the proportion of high school students without jobs is about 0.74, with a margin of error of 0.138. Both students reported the margin of error based on 2 standard deviations from their simulations. What are the mean? So that's 95% confidence. What are the mean and standard deviation each student found? All right, so first we're going to take a look at Elena's. So Elena's proportion is about 0.70. So Elena all right, so her mean is 0.7. Since that was the estimate that was given. And her standard deviation if you take the margin of error, so her margin of error is 0.280, but remember, you need some of it on each side, and it's the same amount on each side. So 0.280 divided by 2 gives us 0.140. So her standard deviation is about 0.14, because to give the interval, she would subtract 0.14 and add 0.14. Okay, so now let's take a look at Claire. So Claire's mean is 0.74. Because that was her estimate. And then her standard deviation is 0.138 divided by 2, which gives us 0.069. So her standard deviation is a little bit smaller than Elena's. But she also had a smaller margin of error. All right, part 2. Claire and Elena try to figure out why Claire had such a smaller range of values in her report. So first, they consider the proportion they used in the simulations. Elena says, my simulation used 0.7 as the proportion since I found that proportion in my original sample. Claire says, my simulation used 0.75 as the proportion since I found that proportion in my original sample. The students used different proportions in their simulation. Do you think this is why Claire had a smaller margin of error? Well, it's not why she would have a smaller margin of error. It does mean that they would have different mean values, right? But not margin of error. So no, the different proportions should result in different means, but not affect the margin of error. All right, so part B, they look for more differences in their initial sample and discover that Elena surveyed 10 people in her initial sample and Claire surveyed 40 people. Do you think this is why Claire has a smaller margin of error? Yes, because she had a larger sample. So with a larger sample, a larger number of subjects in the sample, she was able to capture more of that variability, right? So with a larger sample, Claire captured more population variability. All right, we are not going to do 11.3. And then you can take a look at the summary if you want to learn a little bit more or recap the lesson.